Hi, welcome to my Factoring Quadratics workshop. So first, a little bit about DYC. DYC is a nonprofit organization that allows student leaders like myself to volunteer in the community by showcasing and teaching our talents and abilities through free online workshops. To learn more, visit www.designyourcareers.org. This is our community impact. The DYC platform provides youth with limitless opportunities and gives leadership recognition for their contributions to stand out in colleges and future careers. So this is what we're going to cover in this workshop. First, we're going to learn a little bit about me. Then we're going to learn how to factor by GCF, grouping with 3 terms and 4 terms, then by perfect squares, completing the square, sum or difference of cubes, and the quadratic formula. So this is me. My name is Ashitha Puvvvada, and I'm a student leader at DYC. And I'm a freshman at Innovation Academy. So this informative and engaging pre-recorded workshop is intended to teach all of you different ways to factor quadratics. In order to understand the topics covered in this workshop, you should have prior math knowledge with variables such as x, basic mathematical functions like addition, subtraction, division, multiplication, and radicals, so square roots, squares, cube roots, cubes, like that. So first, we're going to cover factoring by GCF, also known as greatest common factor. Before we get into this, however, we should understand what a GCF is. So what is a GCF? A GCF is the largest number that is a common factor of 2 or more numbers or terms. So for example, the GCF of 6 and 9 would be 3 because it is the largest number that is a factor of both terms. Another example would be 12 and 4. GCF would be 4. So now that we know what a GCF is, we can learn how to factor by GCF. This means you factor out or take out the GCF of each term in the quadratic. So take, for example, the polynomial 6x minus 66. So first, let's identify the 2 terms. That would be 6x and then 66, negative 66. So now we need to factor out the GCF. Keep in mind that you can also factor out variables like x, but you can't do that for this one because there's not an x here in the second term. So for this quadratic, the greatest common factor is 6, right? Because 6 times x would be 6x, and there's no other greatest factor. And then for 66, 6 times 11 is 66. Okay, and then, so basically when you factor out the GCF, you divide the quadratic by the GCF. So 6, like I just said, 6x divided by 6 is just x, and negative 66 divided by 6 is negative 11, which gives us x minus 11, as you can see here. Then you put in the parentheses and put the GCF outside, so like so. And then if you wanted to do it, expand it again to understand how this works, we would do 6 times x, so that's 6x, and 6 times negative 11, negative 66, right? And then another way to tell if you've really factored out the greatest common factor is you can see that x and negative 11 have no other factors that in common. So let's do another example. So this would be one of those instances where you would factor out a variable. So first let's focus on the coefficient -5 and the constant -10. So what is the GCF of 5 and -10? Well, that would be 5, right? So let's factor out our 5. So that would be x squared. And then, so we would get this, x squared minus 2x. But wait, there is more. You can still factor out the variable like I said previously. So our first term after we factored out 5 was x squared, right? Which is essentially x times x. So you can say that the only factor of x squared is x, right? X and x. And then x is also a factor of negative 2x, right? Because negative 2 times x is negative 2x. So therefore, x would be the GCF of the remaining part, this remaining part. So we'd multiply the x with the 5, so we get 5x, and in parentheses, x minus 2. So GCF, the entire original quadratic would be 5x. This is what it would look like here. This is our final factored form. So the way I did it is I broke it apart into whole numbers and variables so you could understand it a bit easier. But you could also have done this in one step. I just did it like this to keep it a bit simpler. You could have recognized that 5x is the GCF just by looking at the original quadratic. So just from looking at this, I could have said, okay, I can factor out 5x. And you would just put your parentheses 5x in parentheses x minus 2. Okay, so now we're going to do factoring by grouping. So factoring by GCF can also be applied in this next form of factoring, which is factoring by grouping. And this is a bit more complex than factoring by GCF, so I'm going to explain it with an example. So take, for example, the quadratic x squared plus 18x plus 81. Now what you're going to do is first you're going to find the factors of the constant. So this is, which is this term without the variable. Okay, so 81. And then you're going to find factors of this 81 that add up to the second term, 18x. Okay, so what are two factors of 81 that add up to 18? That would be 9 and 9, right? So 9 times 9 is 81, 9 plus 9 is 18. So now basically what we do is we split apart the 18. Okay, so instead of writing it as 18x, we would write it as 9x plus 9x, right? And then if I simplified that further, I would have gotten 18x. But we don't want to simplify it, we want it like this. Okay, and you'll see why. So keep in mind that whatever you split the second term up to should always add up to the original second term and multiply to produce 81, or whatever the third term is, the constant. Okay, so now that we've split our second term part, right? So now comes the fun part, at least in my opinion. So you kind of like split it in half like this, right? So you have your first two terms and you have second two terms. You have a red half and your blue half. So now what you do is you basically just do factoring by GCF for each half. So let's do the red one first. The GCF for the red side would be x, right? And then for most quadratics where the first term is x squared with no coefficient like this, x will most likely be the GCF for that first half. But it won't always be that, I'm just pointing that out. Okay, so for the right half, our GCF was x, right? So it would look like this, x, and then in parentheses, x plus 9. And then for the blue half, here we have 9x plus 81, right? That came from here, we just split it in half. So here the GCF would be 9. So if we factor out our 9, we leave x plus 9 in the parentheses. Okay, so now that would look like this, and then this would be how it would look. And you might notice that the part in the parentheses for both of these is exactly the same. Both of them are x plus 9. If you think that's just a coincidence, you're wrong. In fact, if the parts inside the parentheses are different, that means you've actually done something wrong, because those two should always be the exact same. So it's not just a happy coincidence, it should be exactly the same. Otherwise, you've done something wrong. So let's say I had x plus 9 and x plus 8, that would mean I've done something wrong and should go back and look at what I've done. So once you've ensured that the parts inside the parentheses are the same, you can combine the parts outside the parentheses. What I mean by that is you take the GCF from the first half, right? So we have x. You take the GCF from the second half, which is 9, okay? And you put that into one parentheses. And so this is our final factored form. So for the final factored form, I would take this GCF and this GCF, put them together, x plus 9, right? Okay, and then you in the second parentheses, you put this x plus 9 again. Okay, here it's exactly the same. It won't always be like that. Okay, and keep in mind that you only put it once. Even though I have x plus 9 here and I have x plus 9 there, I only put it once, right? Because it should be exactly the same. So I put it once. Okay, so these will not always be the same, like I just said. So here it's x plus 9 and x plus 9. You could also write that as x plus 9 squared. But sometimes it won't be, and that's completely fine, as long as the parentheses here are exactly the same. So we're going to do another example of factoring by grouping, where the first two terms, the x squared part here, has a coefficient. So our polynomial will be 5x squared plus 6x plus 6x plus 1. So in this case, you don't need to find the factor of the constant. In this case, it would be 1. So you don't find the factor of the constant that adds up to 6x here. In this case, you multiply the coefficient of the first term, so 5, right? And then you multiply that with the constant, which is 1. So 5 times 1 is 5. So now we have to split the second term, which is 6x, right, into two terms that add up to 5, not 1, but 5. Oh, sorry, no, that add up to 6 and multiply to 5, yeah. Okay, so the only two factors of 5 actually are 5 and 1, right? So and those add up to produce 6. 5 plus 1 is 6, and 5 times 1 is 5. Okay, so as we can see here, we split it into 5x plus 1x. Look at the way I ordered it. I put 5x first and then 1x. But don't worry. So look at the way I ordered it, and don't worry about it, because it doesn't matter, okay? So what I mean by that is, even if you put it as 5x squared plus 1x plus 5x plus 1, instead of 5x then 1, it's completely fine. Then you'll get the exact same answer, it just your steps will look a little bit different than mine, okay? I just like to put it like this because it looks simpler, like with both the 5s in 1/2 and all the 1s in 1/2. But you can do it however you like. So anyways, after that, you split it in half, right? So you have this half, and you have your red half, and you have the blue half. So now we have to factor by GCF, right? So the GCF for this first half is 5x. So we would factor out the 5x, and we have x plus 1 in the parentheses. Okay, and then for the blue half, the GCF is, so there's technically like no GCF, right? Because it's x plus 1, right? When I say 1x, it's like x plus 1, right? So you'll just put like a 1, okay, because the common factor is 1, right? Just it doesn't look like there's a common factor, but you just factor out 1, and it will be exactly the same, right? Because anything divided by 1 is the same thing. Okay, so you factor out your 1, and you put in the parentheses x plus 1. Okay, so right, and then you factor that out, and then we'll take the parts outside the parentheses for the final factored form. 5x plus 1, you put that in one parentheses. Other one, oh, and both of the parts inside parentheses are the exact same. Keep that in mind. If you're following along, check that both of your parts in both of your parentheses are the same. Okay, so then you take this part, or this part, right? So you just take the part inside the parentheses and put it here. So basically, one parentheses, you have the parts outside the parentheses, and the other one, you have the parts that were inside the parentheses for the final factored form. So our final factored form is 5x plus 1 times x plus 1. Okay, so now I have one last example where we're actually going to use factoring by grouping and by GCF. So I know we've been using factor by GCF, but I mean, when I say we're going to use like we've already been using it when we're like factoring the different halves. But when I say we're going to use factor by GCF, I mean this in a different way. So what we're going to do here is, you can see we have a coefficient next to x squared, right? Like the previous example. But in this case, we're actually going to use factoring by GCF to simplify this polynomial before we use factor by grouping, right? Because we can look at our polynomial, we can see that if we say 80, and it's probably become a bit of a big number, right? Because you have to multiply 80 and 2, it'll be a little bit big, right? So we want to simplify it. So if we look at this, we're going to try and factor out a GCF. So you can see here, the greatest common factor, the GCF, would be 2, right? So we factor out the 2, and then we get x squared minus 6x minus 40. Okay, so we've simplified it by factoring by grouping. Oh, no, sorry, no, factoring by GCF. But now we can still factor this further by grouping. We just did this to simplify it so it's easier to work with, kind of, okay? So now it's like the first example. It's exactly like the first, well, not exactly like the first example, but it's the same steps from now on. So we're going to find the factors of negative 40. Keep in mind that it's negative, not positive, to add up to negative 6. Okay. So the reason that it's important that it's negative 40 is you need to have some sort of subtraction. So here I have negative 6x, right? So we need to, so here it would, so factors of negative 40 would be that add up to negative 6 would be 4 and negative 10, right? So 4 times negative 10 is negative 40. But so that's why it's important that you pay attention to the signs, because if I had done 10 minus 4, it still multiplies to negative 40. but it adds up to 6, not -6. So you have to pay attention to the signs. Okay, so 4 times -10 is -40, and then 4 minus 10 is -6. So it'll look like this. Okay, and keep in mind we still have our GCF outside here. Okay, so now let's do our factoring by grouping for the two halves. So you can see for the purple half, the GCF would be x. So we have x, and then in parentheses x plus 4. And then I forgot. Sorry, I forgot to put the parentheses again here. That's fine. Okay. And then for the pink half, it's -10. So that would look like this. You'd factor the -10. And in parentheses, you have x plus 4. That would look like this. And then you can see that Okay, and then you can see that x plus 4 is the same inside both parentheses, which means it's right so far. Okay, and then for the factored form, the final factored form, this is going to look a little bit different from the others. So normally we took the parts outside the parentheses, and we put the parts inside the parentheses. So you still do that, but first actually, you're going to just take the GCF that we factored out and put it here. Okay, because you need the GCF. So you're going to put that first. We'll write the GCF that we initially factored out. In the first parentheses, we'll put the part outside the parentheses, x minus 10, same as the other examples. And then in this one, x plus 4. Okay, and then you don't have to, keep in mind that you don't have to write it in this order. You can write x plus 4 and then x minus 10, but the GCF should be first. Okay, so now we're going to do a very similar topic. Factoring by grouping, same as the other past 3 examples, but this time we're going to do it with 4 terms instead of 3. The process is very similar, except you don't have to do that step where you split the second term into factors at the constant, like multiplying it, then splitting in half, and yeah, all that stuff. You don't have to do that, okay? So it's a little bit easier. Let me show you an example. So here we have the polynomial 12x cubed minus 9x squared plus 4x minus 3. As you can see, there are 4 terms in it instead of 3, right? It looks very similar to what it looks like after we split the second term in a 3-term polynomial. Well, actually, no. Keep in mind, here, you can see it's 3x, then x squared, and then 4x, right? In previous examples, actually, if I go back, you can see the parts that you split in half should have the exact same sign, okay? But here, it's x squared, and then here, it's 4x, okay? So it's just something that's different. Keep in mind when you're doing this one, that the sign should be exactly the same for those two. The exponent should be exactly the same for the variable when you split that second term in half. Okay, anyways, moving back to factoring by grouping with 4 terms. So we have our green half and our orangey half. For the green half, the GCF is 3x squared. Okay, so we factor out 3x squared, in parentheses 4x minus 3. Then for the orangey side, it's the same as the other example where it was like the GCF was 1, so it didn't look like there was a GCF, but there is. So it's 1 plus 1, and then in parentheses 4x minus 3. Okay, so in parentheses, we have 4x minus 3 inside the parentheses, right, for both of them, which indicates that we have done everything correctly so far. Okay, and then, well, you might have made some mistakes, but at least right, this part is the same. Okay, so then in our final factored form, we're going to take our 3x squared plus 1 and 4x minus 3 from inside the parentheses. And then this is our final factored form. So since this is very similar to the previous topic, I'm not going to do another example. It's basically just the exact same thing, except you don't split that. You just skip a step. So I'm not going to do another example. But next, we're going to learn perfect squares, factoring by perfect squares. This is actually quite a simple way to factor, but it only works on specific quadratics. As you can see, there's 3 rules that it must follow for you to be able to use factoring by perfect squares. Sorry. Okay, so on the bottom of the slide, you can see these different rules. So the first rule is that the coefficient, variable, and constant. So basically, I'm saying each of the terms should be perfect squares. So here you can see that we have, so a perfect square is numbers like 4, 9, 16. So just in case you don't already know that, 2 times 2 is 4, 3 times 3 is 9, like that. Okay, so examples of perfect squares would be like 4, 9, 16. And then for variables, it would be like x squared or x to the 4th, like that. So as you can see in this example, the coefficient, which is 9, is a perfect square in this example here. Okay, it's a perfect square. Since x squared is a perfect square, right, because x times x is x squared, and then 4 is also a perfect square. So it checks off the first rule. Okay, so then the next rule is that the quadratic must always be subtraction. So that might sound a bit confusing, but what I mean by that is, if you look at this example, x squared minus 4. It cannot be plus 4. It can never, ever, ever be plus. It can only ever be minus. Okay, this is very, very important. Okay, you can, if you see, look here too. So this is basically like how you would see it, right? So it's kind of like a formula, kind of a formula version, a template, or I guess, of these rules, right? So they're saying a squared, which means it's a perfect square, right? And then b squared is a perfect square, and then it's always subtraction, and then it's two terms, as you can see, which leads me to the final rule, which is that it must be two terms. So if you look at this one, you can see in both the example and this how you can see it, it's only two terms. Only two. Not 3, not 4, but 2. This is very crucial to factor it. And you'll see why it can only be two terms once we start factoring. So let's now practice using this technique. So I used the same example from last time, and we're just going to factor this. So the trickiest part to this method is probably just ensuring that you can actually use factoring by perfect square for a certain quadratic, just like ensuring that it checks all those rules. After you identify that, it's pretty easy because you just have to memorize this formula, kind of, okay? So let's look at this example so it makes a bit more sense. We have the same example from the last slide, right? 9x squared minus 4. So we've already ensured that it follows the rules, right? So it's both perfect squares, right? This would be square root of this would be 3x, and of this would be 2. And then, right, and then it's a subtraction, yes, it's two terms, yes, right, okay. So now that we've checked that it adheres to the rules, which it does, it's time to factor it. So, one second. Okay, so we literally just need to follow this pattern over here. Pattern, template, formula, whatever you want to call it. So this template / formula, it says a squared. So notice that it says a squared and b squared, and this is how you will see it, right? So that's because when you factor it, you use the square root. So you can see in the factored form formula / template, it says a plus b and a minus b, right? Not, so why is it a squared here? Well, that's why it was so important that these two terms are a perfect square. Okay, so let me show you. So to factor a quadratic, we just need to fill in this template. So let me just show you so it makes more sense why this is a squared, okay? So let's do the first parentheses. A is the square root of the first term, right? A squared, so a is the square root of that. So what they're saying here, the reason they put a squared is they're saying that here you want the square root of it. So the square root of that would be 3x, right? Okay, 3x. And then plus b, right? Plus b. So that would be 2. And keep in mind that it's plus 2, right? Minus 2, it's plus 2. Okay, but the next one, okay, the next one, it's essentially going to be the opposite. It's 3x minus 2 instead of plus. So we're gonna expand this to see kind of like how it works. Okay, so I've already multiplied it out, but I haven't simplified it yet, so you can see like why this works. So you can see that here we get minus 6x and plus 6x when we multiply it out, right? So 6x minus 6x, that cancels each other out, right? So hence the two terms, because these two terms will always cancel each other out. That's why it's plus and minus, right? So here I do 3x minus 2, and then I do 3x plus 2, right? So then it'll cancel each other out. That's why it's always going to be two terms. So let's do another example. So here's the second example. It's pretty simple. So let's first check that it follows the rules. Has two terms? Yes. Is it subtraction? Yes, x squared minus 1. And then are both terms perfect squares? Yes, x times x is x squared, and 1 times 1 is negative well, 1 times 1 is 1, yeah. Okay, so now let's factor it. Now let's factor it. For the first parentheses, let's find the square root of both terms. So we have x squared. So square root of that would be x, right? So x, and then the square root of 1 is just 1. 1 times 1 is 1. So x plus 1. The second one, we would have x minus 1. Okay, simple as that. It's really easy. Okay, so next is completing the square. This is a little bit of a lengthy process, but it'll definitely be useful. So let's look at it. We have our trinomial, right? So first we take the constant 12, okay? Let me move it to the other side. So we subtract 12 from both sides, which leaves us with this. X squared plus 8x is equal to negative 12. Minus negative 12, right? Because you subtract negative 12 from both sides, so you get negative 12. Okay? So then we take the second term, right? Our 8x. Then you take the coefficient, which is 8. You divide that by 2, so you get 4. Then you square it. Okay, so that's 16. Okay? And you add that number to both sides. Okay, so you have x squared plus 8x, and then we said 16, right? So plus 16 here, and plus 16 here. Okay, you have to do on both sides, right? Because that's how like the equation works. Has to be whatever you do on one side, you have to do that to the other. Okay, so now the left side is now considered a perfect square trinomial. So we're going to take the x squared plus 8x plus 16. We're going to factor it, and it becomes x plus 4 squared is equal to 4, right? Because we simplified this. So we take the square root of both sides. Since x plus 4 since x plus 4 is squared, the square cancels the square out, and we just have x plus 4 on the right side. Then we have the square root of 4. So what do you think the square root of 4 is? If you said 2, you're right, but not entirely right. When we're doing completing the square, when we take the square root, we take the plus and minus square root, right? Because normally you just think 2, right? Because 2 times 2 is 4. But it can also be negative 2, right? Because negative 2 times negative 2, negatives like cancel off and become plus, right? So negative 2 times negative 2 is also 4. So we have a plus and minus 2 as our square root. So then we solve for x. We take 4 to the other side. We take this 4 to the other side, so x is equal. So we subtract 4 from both sides. So we have x is equal to negative 2 minus 4, right? Because we have plus 2 and minus 2. So plus 2 minus 4 is negative 2. And we have minus 2 minus 4 is equal to negative 6. So we have x is equal to negative 2 and negative 6. And generally, when you're factoring, you're looking for what x is equal to. So it's like, right? So this is useful because it allows you to skip that step of like the factored form and using the factored form to find x is equal to. But if you do need it in factored form, you would just do x plus 2 in parentheses times x plus 6 in parentheses. And this works because we have x plus 2. So if we set that equal to 0, negative 2 would make make it true, right? Negative 2 plus 2 is 0, right? And then the same for x plus 6. Okay, so let's do another example. Okay, yeah. So first, we're going to, right, we have x squared plus 2x is negative 48. X squared plus 2x minus 48. So first, let's take the negative 48 to the other side. So in the last one, it was negative 48 on this side. We're adding it to both sides, so we have 48. So x squared plus 2x is equal to 48, right? So we're going to take, which term? We're going to take the second term. And we're going to take its coefficient, 2. We're going to divide it by 2, which is 1. We're going to square that, which is 1. Right? So we're going to add 1 to both sides. So x squared plus 2x plus 1 is equal to 48 plus 1. Okay? And then this is our perfect square trinomial. So we can just factor it to x plus 1 squared. And that's equal to 49 once we've simplified it. Then we're going to take the square root of both sides. And keep in mind, you have to take the square root of both sides. Because, right, anything you do one side, you have to do it to the other side. So that leaves us with x plus 1, because the square root and the square cancel each other out, and then equal to plus minus, keep in mind, plus minus 7. So then we're going to subtract each side by 1 to take 1 to the other side, which gives us x is equal to So we have plus 7, right? So 7 minus 1 is 6. We have negative 7 too. So negative 7 minus 1 is negative 8. So x is equal to negative 8 and 6. Okay, so now we have, okay, so our second to last topic is sum/difference of cubes. So first and foremost, for this to work, both terms must be perfect cubes. There should be 2 terms. Now I'm going to go over these 2 formulas, I guess you could call them. So the first one is sum of cubes, and that is, as the name suggests, when 2 cubes are being added together, right? It's a sum. And then, so the y cubed will likely be some number that is a perfect cube, like 8 or 27, but it's not always. It can also be another variable. Anyways, so much like the last one, there's a fixed formula for how you will factor polynomials that look like this. So in the first parentheses, you'll have x plus y, which is basically the cube root of the first term, right? So x cubed. So you have just x, right? So it's cube root of x cubed. So we have just x here, plus y cubed. So whatever the cube root of that second term is, it's going to go here. So x plus y. Keep in mind it's plus, right? Because it's a sum of cubes. Sum. So it's addition. Okay, in the second parentheses, you're going to square the cube root of the first term. Okay, and that might sound a bit wordy. It'll make more sense when we go into an example. So we have x plus y, right? Well, yeah, we have the x plus y in this second parentheses. We're going to take the square root of, okay, so, yeah, we're going to take the square root of x. Okay, so but yeah, so basically we're just going to take the square root of x. Okay, so here it was x cubed, right, and y cubed. We're going to take the square root of x. You can just look here, right? So just square this, put it here. Then it's minus. Keep in mind it's minus. I know it's sum of cubes, but here you're going to have a minus, okay? You're going to have minus. Just multiply your x from here and your y from here. So x times y, so minus xy plus, then you're going to take this y and squared, so y squared. So the formula for that is x, so it's x plus y in parentheses times x squared minus xy plus y squared. Okay, so now for a difference of cubes, this is when one cube is being subtracted from the other. So it's the exact same as the sum of cubes, except there's a minus here. I mean, no, sorry, a minus here and there's a plus here instead of a minus. Okay, so the first parentheses will have x minus y, right? Because it's difference of cubes, right? You're doing something minus other. Okay, so you'll have x minus y, again, that's the cube root of x cubed minus the cube root of y cubed. So x minus y in the first parentheses. And in the second parentheses, you'll square this x, right? And then you'll add, okay? I know this seems kind of weird because, right, in the sum of cubes, it was a minus. But in the one where it's subtraction, you have a plus. But that's just how it is, okay? So we have plus, then we multiply the x and the y, so plus xy, plus, and then you square the y, so y squared. So for difference of cubes, the formula would be x minus y in parentheses times x squared plus xy plus y squared. Okay, so let's do an example of this. I'll start with something simple. X cubed plus 8, and I kept the formula up here for reference. So this is, first we need to identify what this is, right? And this is the sum of cubes. Right, so this is the formula we would use. So let's start with the first parentheses, which is x plus y. So so much like the formula, right? It was x cubed. So what is the cube root of x cubed? That's just x, right? So first you put x here, and then what is the cube root of 8? That's 2. 2 times 2 times 2 is 8. So x plus 2 in the first parentheses. And the second parentheses is going to be x squared, right? So we're going to square this term, so x squared. And here we're going to do minus. We're going to multiply these two terms together. So that's 2 times x, which is 2x. So x squared minus 2x. And then we have plus, okay, yeah, and then we're going to square this term, which is 2. So 2 times 2 is 4, so plus 4. So overall, the factored form of this will be x plus 2 in parentheses times x squared minus 2x plus 4. This is very simple, okay? Because we just need to follow the formula. Now let's do an example of a difference of cubes. So keep in mind that this is difference of cubes and not sum of cubes, as you can tell by the minus sign in between the first and second term. Okay, so we have 8x cubed minus 27. Let's start with the first parentheses, which is x minus y. And here's our formula up here for a difference of cubes for reference. So first we need to do the cube root of 8x cubed. So we have to do the cube root of the coefficient and the variable, not just the variable or not just the coefficient. So the cube root of 8 is 2, and then of x cubed, it's x. So we would write 2x, and minus, and then y. So what is the cube root of 27? That would be 3. So 2x minus 3. And then in the second parentheses, we have to do x squared. So what is 2x squared? That would be 4x squared, because you have to square both the coefficient and the variable. Then plus xy. So that's basically just multiplying this and this. So you can just look at the first parentheses and multiply these two terms for the second term here. So 2x times 3 is 6x, so I say 4x squared plus 6x. Then y squared, so that's 3, so I say, so 3 squared is 9, so 4x squared plus 6x plus 9. So this is our factored form for a difference of cubes. So again, this is just remembering the formula, or if you're given the formula, it's even simpler. So yeah, you have to know how interpret this formula. Okay, so time for the last topic of the workshop, the quadratic formula. So by using this formula, you can skip all the steps of the previous method and just insert different parts of the polynomial into a formula. So this is our formula over here. So I haven't really referred to so if you see this part over here, I haven't really referred to the parts of the polynomial like this with the a and the b and the c, but it'll be helpful to know now. So as you can see here, a is just the coefficient of the first term. So how we've had 8x squared plus 3x plus 2. So 8 is the a, and then I said 8x squared plus 3x, so 3 is b, and then plus 2, so c is 2, right? It's like that. So for the quadratic formula, what you're doing is just inputting these coefficients and constants a, b, and c into a formula to solve for x. So I generally only use this formula when I can't use factoring by grouping, but there are many people who just use this formula for everything. Anytime they need to find what x is equal to, they use this. You're free to do whatever you want. I just enjoy factoring by grouping, so I prefer to use that if I can. Anyways, let's look at an example to understand how this formula works. So this is our first quadratic, and we're going to solve for, just something I don't know if I mentioned. So the quadratic formula, you're solving for x, okay? So we're going to put this into the quadratic formula. I'm actually going to write this one out because there's fractions and square roots and it's just annoying for me to type it. So I'm going to switch that tab. Okay, so here's the quadratic or polynomial that we're going to be factoring / solving using the quadratic formula. So first, let's identify the terms, well, not terms, the a, b, and c. So first, let's do a, and I'll do this in the same color as it is here. So a, okay, so a, so we said it's ax squared, right? So a would be over here, and I didn't leave no space for it. Fine. Okay, so that would be over here-ish, right? But you might think there's nothing there. So obviously there's no a, right? It's 0, it's nothing. It's disappeared, right? So actually it's not 0, it's 1, right? Because 1 times if you multiply something by 1, it's the same thing, right? So x squared times 1 is still x squared. So it's multiplied by the coefficient is 1. We just don't write it because it's essentially the same thing. And it's just a waste of a character. But yeah, so technically it's a, it's not 0 or something. It's 1. Okay, so then let's do b. So b it was b x squared plus bx, right? So b would be here. And then the last part was plus c, right? So that's this part. And keep in mind that it's negative 34. The c is not just 34, it's negative 34. Okay, so now let's actually like input it into the formula. So first I have negative in parentheses, so the c is plus. Okay, so actually I'll do this in the same color. So negative b, right? Okay, so b was 2, right? So I just put it in 2. Okay, and then square root, and then squared minus 4. Okay, that was. And then 2. Okay, so now we're just going to basically just like input stuff into here. So b is 2, so I put it in there. Negative 4 times a, right? So a is 1. 1. And then times c, right? C is what? Negative 34. Okay, I apologize if that's kind of hard to read. I didn't leave enough space for that. Anyways, so, and then 2 times a, right? And a is 1. There. Easy as that. And then we just have to simplify it. So let me do, okay, fine, I'll just do this over here on the bottom. So negative 1 times 2, that's just negative 2, plus minus square root of, so this part would be 4, right? 2 squared is 4. And then this is negative 4 times negative 34 times 1, and then like the 1 doesn't really matter because it's 1. So negative 4 times negative 34 is positive 136. So this is 136. Right, so if I added those together, that would give me 140. And 2 times 1 is 2. Okay, so that's essentially it. X is equal to that. And keep in mind that it's not, x is equal to negative 2 plus, okay, actually, before I say that, first I would like to point out that I know this looks like a really, really yucky number. It's like negative 2 plus minus square root of 140 divided by 2. I know it looks like really long and big and complicated. It doesn't look that complicated, but like, you know what I mean? It looks big. Okay, it looks like big and yucky. Okay, like normally you'd be like really clean numbers, right? Like 4, 3 whole numbers, you know? But this is long. Okay, and just because you get some long yucky number like this, that does not mean it's wrong. Okay, I know we're used to having like whole numbers and stuff, but no, sometimes we get yucky numbers like this, and that does not mean it's wrong. I mean, sometimes you did it wrong, and if you get a yucky number, it's wrong. But not every time that you get a yucky number, it's wrong. You know, it can be like sometimes it's supposed to be like that. Anyways, as I was saying before, this is actually not just one solution. This is 2 solutions. So we're saying x is equal to negative 2 plus minus. Plus minus means it's plus or it can be minus. Okay, so that means x is equal to negative 2 plus the square root of 140 over 2 is one value of x, and then x is also equal to negative 2 minus the square root of 140 over 2. Okay? So now let's delete this all. This. Okay, yeah, let's just there. Okay, perfect. So now we have so this is our second one, 4x squared minus 7x. So first let's identify our terms, right? So ax squared, so this is our a. This is our b, negative 7. But now, in the last one, a was missing, right? It disappeared. It wasn't there. It was, right? So it was 1, right? In this case, where's our constant? Where's our c term? It's gone. Whoa. It's not gone. Well, it's not, it's technically gone, I guess. It's not gone. It just, you don't write it. It's plus 0. Right? And because 0 is like nothing, essentially, right? It's nothing. So you don't write it because it doesn't affect our quadratic, but technically, yeah, our constant would be 0, our c term would be 0, okay? So now let's input this into our formula. So negative b plus minus the square root of b squared minus 4ac. And I apologize for my very messy parentheses. And 2 squared, not 2 squared, 2 times a. Okay. So now we just need to input our a, b's, and c's into the formula, right? So b is -7, right? And this is one of those times when the sign is very, very important, okay? Because right here it's -7, right? Do not assume, like here it's -b, right? My b, just because my b is -7, do not assume that like it's because it's -7, it just be like it's like -7 plus minus. No, because it's -1 times b, which is -7. It's -1 times -7. It's not like because there's already a negative in the b, you don't count the negative here, right? It's not like that. It's negative times -7. Okay, it's not just -7. Okay, so anyways, plus minus the square root of, and then b again, right? So -7. -4 times a, right? So that's 4. And then c is 0, right? Here, and then 2 is, a, right? So then 4. So 2 times 4. Okay, so now let's simplify this. So this is 0, right? It's times 0. Anything times 0 is 0, right? So this is non-existent now. Okay, because it's 0, right? It's nothing. So this will not affect our answer, so we don't need to worry about that now. Okay, so now we have this, right? Negative times -7. Not just -7, -1 times -7. So because the negative and the negative will cancel out, right? And it'll become positive. So that means it's 7. See how if you had assumed that like the negative takes the place of the other, like because there's already a negative there, you don't need another negative. If you had assumed something like that, you would have gotten the wrong answer. You need, it should be negative times -7, not -7, just -7. Okay, anyways. -7 plus minus, and then this is what is -7 squared? That's 49, right? So actually, yeah, so 49, 2a, 2a, well, 2a was 4, right? So 2 times 4 is 8. And then this is 7, right? So 7, so let me actually just erase that. So just 7 plus minus, give me a pen, 7. So now let's get our answer. X is equal to, so this is 7, so this is 7 plus 7 over 8, and 7 minus 7 over 8. Okay, so this and this, right? So this is equivalent to, so 7 plus 7 is 14, right? So 14 over 8, and that simplifies to 7 over 4. And this is 7 minus 7 is just 0, right? So 0 over 8 is just, I don't even need that line over there, just 0. So x is equal to 0 and 7 over 4. And now something that might be confusing you, that might have been confusing you over the course of this workshop. I know I mentioned it once, but it might not have made sense to you because I didn't really like explain it. So I'm just like briefly. So you might be wondering, why do how come some methods give us x is equal to this, and some give us like those things in parentheses where it's like x plus 4 times x minus 4, right? So that's how I'm going to explain right now, actually. So I want you guys to understand that. No. Okay. So let's look at this. So we have sometimes like by factor by grouping or factor by GCF, we get something like maybe x plus 4, x minus 4, right? And then sometimes we get x is equal to 4 and -4, right? Like through the quadratic formula or something. Okay, So a lot of the times when you're trying to factor, or if you're factoring your polynomial, you're trying to find what x is equal to, right? You're trying to find this, which is what you get with the quadratic formula. But sometimes you also want the factored form. So I'm gonna explain what both, like, the difference between both of those is, and like how one is like how they're interconnected, kind of. Okay. So first, I'm going to explain what is this? It's the factored form, right? So how can you use this to get this, right? Because a lot of the times, this is what you're looking for when you're factoring. You want to like know what x is equal to. That's what when you're solving. So I'm going to show you first how to make this into that. So essentially, all you're going to do is so first we're going to like set, so this is like equal to 0, okay? We're going to set it equal to 0. So now what we want to do is we want to make this equation true. Right, so how do you make this 0, right? We have all this like 4, -4 and stuff, right? Well, if you multiply, how do you get 0, right? If you multiply something with 0, it becomes 0, right? You need to like already have a 0 in there. So one of these needs to be 0, right? So essentially, so basically what you're gonna do is to find what x is equal to, you have to like you have to find the value of x that will make this equation true, right? That's what you're generally doing when you're solving for a variable, right? Like if you're solving for x. So now we're just like solving for x. So x plus 4, right? So if I make x -4, if I make it -4, -4 plus 4 is equal to 0, right? And anything times 0 is 0. So even though -4 here would make this -8, make it -8, right? -8. Even though this would become -8, this is 0, right? So 0 times -8 is still 0. So that's true. So one value of x is -4. And then it can also be, well, that makes this one is equal to 0, right? But this one can also be equal to 0. So in this case, you would make it 4. And then it would be like 4 minus 4 is 0. And then even though this one becomes 8, 0 times 8 is still 0, right? And that's the same thing as this, right? So that's like one of the benefits of using like the quadratic formula. It already gives you the like what x is equal to, but sometimes you want the factored form, right? So now I'm going to show you how to make this into factored form. Actually, wait, no. So first, I'm actually going to show you some like more like complicated, not complicated, just like another like way that you might see it. Yeah, yeah, it's kind of just like a more complicated version. Let me actually just like erase all of this. Okay, so another like not way you would see it, but just like another way that something might be factored, something like this, where you have like a coefficient for x, 2x minus 3, and that is a very messy parentheses. 2x minus 3 and x minus, I don't know, plus 2. Okay? So you can already tell that it's like a little bit different from the last one, right? Because you have like this 2 here, you have like a coefficient, and you have an x outside of it, right? So let's see how you would find x from this. Okay, so x is equal to, and we're gonna find our, so little spoiler alert, we're gonna have 3, okay? And I'm gonna fill these in as we go along. So first, let's do this one because we basically already did that, right? We just need to figure out something that like cancels out the 2 to make it 0. So that would be -2, right? -2 plus 2 is 0. So -2 is one of our values of x. So now let's do this one. So basically what you're doing is you're just taking this part, you're ignoring the x, this part, switching the sign, right? So +2, -2. So here, -3 is +3. But wait, what about this coefficient? Right? Because if I put just 3, 2 times 3, right? Because you have to like there's a 2, right? So 2 times 3 is 6. So 6 minus 3 is just 3, right? And that's not 0. So we need to figure out a way to get this 2 out of the way too. Okay? So you just have to take this 2 and put it in the denominator. Whatever the coefficient is, that will go in the denominator, okay? So it's 3 over 2. And I'm just going to show you how this like works kind of like, so let's see, we have 2 over 1, right? And then minus 3. So 2 times 3 is 6. 6 over 2 is 3. 3 minus 3 is 0, right? So that's how that works. And let's Okay. So then we have this one. Whoa. It has no like number or anything next to it. Well, that's why it's just 0. If you see an x outside with like not in the parentheses, it's just like this, it's always gonna be 0, okay? So what you want to do. So like if there's no like minus this plus this like that, it's just 0. If there's a coefficient, like 4x, it's still gonna be 0, right? Because 4 times 0 is 0, and then everything is 0, right? So as long as it's like outside and there's no like -3, it's not in parentheses or anything with them like -3 plus 3, whatever like that, it's going to be just 0, right? Because there's nothing that it needs to cancel out, right? Like here, if I just put 0, there's still this plus 2, so 0 plus 2 is 2, right? But here, there's nothing that needs to like cancel out in order to become 0. So it's just 0, right? And it stays 0. So that's how that works. So now I'm going to show you how it will work if, let's say you wanted the factored form. For some reason, you wanted the factored form but you used the quadratic formula and you got how x is equal to this, this, this. So now I'm going to tell you how you could like convert that, okay? So this is basically just working backwards. Let's say if x is equal to, I'll do something simple, 2 and -7 over 3. Okay, so, and then, and let's say it's 0, 2, okay? So I have my 2 parentheses, and I'm going to put 4 blanks in here, okay? And those are the different like values that we're going to have. So the second one is always going to be x, okay? And here we're going to have our coefficient for x. Here we're going to have, and here we're going to have the sign, and here we're going to have like the number, okay? Coefficient, sign, number, and then here's x. Let's work on the first one, okay? So the first one is 2, right? So how do we use that into our like factored form? So when we were working backwards, we took this part, right? Then we just switched the sign, right? So if it was -2, we switched the sign, and then our x was equal to just 2, right? Not -2, but 2. We just switched the sign. So yeah, right? So we have 2 here. We switch the sign, it's -2. So basically, if you're just like working that, so when you're making a factored form, you just switch the sign, and then when you're making it into like factored form into x is equal to this, you switch the sign. So yeah, I basically just like switch the sign. So this one is -7 over 3. Keep in mind it's negative. So we're gonna put positive in the sign here. And then which one did I say would go here, the numerator or the denominator? It was the numerator. So we put the numerator there. We put the denominator here. Okay? So we put the denominator here, so it looks like this. But wait, there's a 0. What about the 0? Remember what I said like a second ago? If there's just an x here, it's 0. Whoa, like that. And technically, just from looking at this, you can't really know if it's like a 4x or a 5x or something. But yeah, that's like the general gist of it. So that's how they're kind of like interconnected. So yeah. So that was the last topic of this workshop. If you'd like to learn more about DYC or get involved as the student leader, please visit these links. And thank you for watching my Factor and Quadratics workshop. I hope you've learned many of the different methods to factor and solve quadratics. Bye!